Okay, so I want to start, this is the Christmas gift worksheet, and I want to start with number 6. Okay? I got the rest on a different video, so we'll go ahead and just start with number 6. Good review. Here we go. Write the equation of the ellipse centered at the origin with vertices at -1 and 1, 0, and 0, 6, and 0, -6. Oh my. This is like too easy. Write the equation of the ellipse. Okay, remember what equations of ellipses look like? That's what they look like. That's an ellipse. So somehow, based on what we've been given, that's all we've been given, but that's enough. We have to fill in all those blanks. So tell me, where should I start putting in empty spaces? X minus 0. Isn't our center at the origin? So that would be 0, 0. So I don't even really need to write that. You could just write it x squared plus y squared. That's fine too. Whatever, it makes no difference. Whatever's the most comfortable for you. All right, what about the denominators? 36 for the y. We know that's 36 because look, didn't you count up and down 6? Which means that number has to be 36. And then 1, because we counted sideways 1. And that's it. That's the answer. That was too easy. Well, number 7, I'm not even going to draw this. Normally I draw everything, but for this question, it says find the lengths of the major and the minor axis. Find the lengths of the major and the minor axis. Well, think about drawing this. What would that 9 tell you? Underneath the x term, what would that 9 tell you?
3.
You're going to go 3 forward and backward. So that length would be 6. And then the 16 says you're going to go up and down 4. So that length would be 8. Well, the longest one is the major and the shorter one is the minor. So I think we can do that without a picture. Now, if you want to draw a picture, that's fine. But if all they want to know is how far you're going, your equation tells you that. Now, number 8 is an entirely different situation. Number 8, we have to figure out what the center and the vertices are. In order to do that, we probably need to rewrite this equation in standard form. So that means doing what?
Completing a circle.
Completing a square. Yep. So the x's are already grouped. Let's pull out a 25. The y's are already grouped. Let's pull out a 4. Everybody, so far so good? All right, so we're going to complete the square. This is going to be a 1, but it's really a 25. This one's also going to be a 1, but it's really a 4. Now, don't just copy those down. Does everybody understand why I put a 25 and a 4 over there? All right, so now we got 25 x minus 1 squared, 4 y plus 1 squared, equal to, what is that, 100? Carefully read the problem. So we end up with x minus 1 squared over 4, y plus 1 squared over 25 equal to 1 because I'm dividing everything by 100. It is so easy to sit there and watch me do it. Are you doing that on your own? Everybody's doing that? Where's my center? 1, -1. So that's the first question. The question said, where is the center? The center is at 1, -1. Now, where are the vertices? There are going to be 4 of them. Those are the points that we're going to connect when we make our oval. So we're going to go left and right, 2. So one vertex is -1, -1. And another one is 3, -1. And then we're going to go up and down 5. 1, 2, 3, 4, 5. So this would be 1, 4. And 1, 2, 3, 4, 5. This would be 1, -6. And those 4 points that I just connected, those are your vertices. Find the center and the vertices. Got it? Write the equation. Oh, now this is backwards. Number 9 is backwards. It's like the one we did a minute ago, except it's harder. The vertices are at 2, 3, 2, -1, 6, 1, and -2, 1. So these are the vertices. And now we're going to write the equation. We okay? All right. What do we know? We know the center is 2, 1. Now, I think most of you, especially if you're doing this on graph paper, you can eyeball that. But if you can't eyeball that, or that doesn't make sense to you, pick a pair and do midpoint. Midpoint is average. What is the average of -2 and 6? Well, -2 plus 6 is 4, divided by 2 is 2. Right? So then we can say x minus 2, y minus 1. That's our center. Now, what about the denominators? Under the x is going to be 16. Now, why is it a 16 and why is it under the x? We went left and right, 4. Left and right is x. And you got to put 4 squared down here. The square root of this tells you how far to go. Right? Up and down. So that number is going to be a 4. Because you counted up and down 2, and 2 squared is 4. One more. Aylish, paying attention?
Yeah.
Okay. Write the equation of the circle with a radius. There's a radius whose endpoints are 1, -2, and 3, 6. This is tricky. Smile face. I don't know what do you think's tricky about it? Can we do this?
Yeah, well, it already gives us the center.
The equation of the circle looks like this, right? So x minus 1, y plus 2. Is that okay with everybody? All right, what goes over here?
The length of the radius.
Well, it's going to be radius squared. Remember, x squared plus y squared equals r squared.
Can we just put this in formula?
We can do the distance formula, we sure can. So that would be the square root of 1 minus 3 squared and negative 2 minus 6 squared. Right? What is that? 4 and 64. So the radius is the square root, but when I square it, I just get 68. Why did I say that was tricky? What assumption did I make?
That was the center.
That this point was the center. All it said was the endpoints of a radius. Could the problem have looked like this? Oh yeah. If all we know are the endpoints of the radius, we don't know which of those endpoints is the center, right? One of them is the center. So the good news is, what do we know about that?
Same thing.
It's the same thing. So all we have to do is adjust our center. X minus 3 squared plus y minus 6 squared equals 68. So this problem, it's tricky because there are two answers. We didn't know which one was the center, and we're going to get a separate equation for each one. Does that make sense to you now that I pointed it out? Yeah. All right. Let's go to lunch. We're going to kill each other running out of the room. And I want you back to your seats at 12:21. 12:21. Meg, would you get that off? Thank you. And we'll do a practice test when you come back, and we'll get that to the last test too. We'll get that